Hello again. Welcome to the lecture on systems thinking, more about what MIS is, and then I'll talk about AI systems and basically use the AI factory framework, which has different components. So I'll talk about what the different components of that are, and let's get started. So what is systems thinking? You're in a class called Management Information Systems. We talk a lot about technology systems. So what does actual systems mean in the context of MIS? It comes from this term called systems thinking, which actually basically says that phenomena have different pieces. There's relationships among different things, and each thing within the system has a shared function. So what I want you to do first is watch the short YouTube video called What is Systems Thinking? You can watch that after this video, or I think it highlights these concepts really clearly. So what I usually do in the face-to-face class is I'll show this video now. So if you go ahead and watch it and then come back to this video, that would be kind of a natural way to do it. But nonetheless, here's a definition of systems thinking. So it's kind of this analytical tool, this way of processing, basically looking at some kind of phenomenon that helps in understanding and solving complex problems. So a phenomenon, a problem, whatever you want to apply, looking at something as a system too. So you focus more on the relationships between various components rather than just analyzing stuff in isolation. So traditional thinking is more just looking at, one thing that leads to another. And systems thinking is realizing that there's a lot of contributing factors to why things happen. And you look at, component one, two, three, four, five, six, and seven versus just single components. And you also kind of approach whatever you're looking at in terms of relationships between components. So instead of just kind of a linear relationship, this affected this, you would look at, different components and how all these things are related. That's kind of like the theory behind it. Um, you can also think of it as a set of pieces that have relationships and collectively perform a shared function. So all these different components over here, would kind of perform this, I'll call it, oops, SF. This is supposed to be an S. So a shared function between them. Um, and basically, you will examine the function in terms of its parts. Um, you talk about, an emergent behavior resulting from the way the components interact. So, what the shared function really is based on all these different components and how they come together to produce something. So, an example of systems thinking can be applied in healthcare. So, a lot of times doctors will look at, you know, a lot of different of your lifestyle factors versus diagnosing your single symptoms. So, if you have symptom one, symptom two, that would lead to an outcome versus looking at your lifestyle factor. And you have, potentially 10 different lifestyle factors that, you know, all kind of affect each other. And then if you change one lifestyle factor, that might change how that factor relates to lifestyle factor number two. So it's kind of a different way of looking at things. And then in traffic, the example is basically you look at public transportation, planning a city, road infrastructure, etc. You kind of look at the whole system of, traffic. You have, buses, you have subways, um, you have, you know, uh, something like that, bike lanes versus if you want to ease traffic, a lot of times cities will just add an extra lane. So if there's already like three or four lanes, they'll add an extra traffic lane and say this will solve the problem. But they're not actually looking at the whole public infrastructure through bus systems, through a subway potentially, or a train, or a bike lane. So it's just a different way of looking at things. So how does this relate to kind of managing a system of information or managing an information system? So remember, this is really the class. We haven't really talked much about this, but this is management of an information system. So what is management information systems really? Hopefully I've kind of inferred this throughout the whole class so far, but it's important to really kind of take a step back and say, okay, how does everything that we're doing relate to MIS? And what does it really mean to manage a system of information? And what exactly is a system of information or an information system? So if you remember, systems thinking is really the set of pieces that have relationships and perform a shared function. So if you look at an information system, the shared function is basically to create, collect, process, store, and distribute basically information from the data, right? So again, we're talking about data. It's always about the data, right? So the system, the actual kind of shared function is to do all of these things, create, collect, process, store, distribute this information. So we all should know that information is not data. Information is data within context. So in order to support decision making, coordination, analysis, and overall, have some control within your organization. So the data really needs that context to turn into information, and then information really needs to be distributed to different people within the organization. So person person A, person B, person C, depending on these are P's for person, depending on what information they actually need. So you need the ability to collect this data, to turn it into information so that these individuals within your organization have access to that information, can make decisions that then affect the business as a whole. So what does it mean to actually manage this information system? So you need to be able to create the data, maintain everything, process everything, strategically plan the whole system around collecting and processing the data, maintain everything, potentially design the system, the infrastructure, the data, the software, those types of things, have relationships with different vendors to secure the system, to continuously improve everything, to manage, relationships with cloud partners, which we'll talk about after the first exam. So there's all these different components that go in to managing this system of information, right? To manage all the data so that it can be processed and distributed to the proper people. Also, I like to talk about MIS people as having the ability to translate human to geek and then geek back to human. So it's kind of the bridge between the needs of the users who rely on the data and the information and the technical requirements necessary to design, implement, and maintain the whole system from getting the data all the way to the user. Okay? So how you can think of an information system is there's 5 components that are usually taught. And this is kind of designing the system to capture, distribute, use the data, basically, to turn it into information so that it can be used and analyzed, etc. So what are these pieces? What are these components of an information system? Remember, all of the different pieces and components kind of work together um, to have a shared goal. So these are really the components. So the first component is hardware. So this is actual the physical technology that supports everything. So this includes things like computers, servers, the networks behind the scenes, the actual storage devices, potentially sensors, and Internet of Things devices that, the actual physical stuff that allows you to collect and store the data. So for example, a company will use a cloud server that actually stores customer data, and that would be an example of the hardware. Then you need the software kind of within the hardware. So the software are really the programs and applications and apps that process all the data. So this includes, the overall operating system, the different database software systems, the different AI and analysis tools, and a lot of different business applications, accounting systems, Excel, that type of thing. So an example, you have different AI softwares that help make decisions. We've been talking a lot about AI and analytics tools that help make decisions. You also have different types of software that help you, understand what you're doing and analyze your data. You have PowerPoint to present your data. You have Tableau to visualize your data. You have a lot of different types of things that go in to, doing your job. And that software needs to be present so that people can perform their business functions. And also the hardware also needs to be present, right? A lot of you are watching this on a computer, on a phone. That is the physical hardware that needs to be there. And you're watching this through Canvas, which is really the software. You're also watching it through PowerPoint, which I created, to distribute this to you. And you're also watching it on YouTube, which is software for, creators, um, that also is based on infrastructure behind the scenes. So it's kind of endless, this system of information that people need to really do what they need to do, right? The five components continue with, of course, data. Data is one of the components. As we talked about, the raw facts and figures that are processed into meaningful information. So this includes, structured and structured data. So you have databases, you have spreadsheets, you have unstructured data, you have videos, emails, text, customer reviews, that type of thing. So an example, customer purchase data history is stored in a CRM, customer relationship management system, which is also a type of software. So you need that data to actually, as you know, to make sense, to really turn into information so that people can use it. People can actually do something with it within a business. And you might take all this for granted because it just kind of exists, but the whole system of information, is built by a lot of different types of people, and there are different components to or different jobs for each of these components. And all those different components are really in high demand because everything nowadays runs and needs an information system. So another component is the processes. So these are the rules, the workflows, and procedures that actually define how the system operates. So you can kind of define the system and what it does, right? So business rules, automation reports, security protocols, decision-making frameworks. Um, so for example, if you have, a machine learning model that automatically detects a different type of bias. Also, a rule could be if you're in a healthcare setting, user A could be a nurse. So a nurse has access to certain information that a patient, I'll just call it patient. This could be user B. A patient, I'll call him Pat, has access to information that they need, and the nurse has access to probably more information than the patient has access to. The doctor also has access to information. So there's all different types of people that have access to different types of information. And the rules of who has access to that, access control, is a part of the process. And then the last component is of an information system is the people. This may seem obvious, but technology is kind of useless without the people using it. That may seem like an obvious statement, but often companies will design all this different technology because it's cool and not that's necessarily effective for the user. So the user and professionals who actually interact with all this information, they're the ones who use this stuff, so it needs to be meaningful and useful to them. So business executives, IT people, systems analysts, end users, data analysts, whoever. So an example, a marketing manager using AI-powered analytics to track the success of their campaign. Also, if you're in a healthcare setting, your people would be the nurse, the patient, the doctor, the pharmacist, whoever, right? You have different people that use different aspects of the information, um, and within the system. So an example, you have electronic medical record systems. So if an MIS person would help design and maintain the software, hardware, everything in the information system. So an example of just kind of breaking that down. So the hardware would be the actual physical devices that support healthcare. So you would want servers and cloud storage to store patient records and make sure everything was secure. You need computers and tablets for doctors and nurses to enter and retrieve patient information. You would need, different medical devices like the sensors on a bed, MRI machines, heart monitors to collect patient data and that type of thing. So there's a lot of examples of hardware in a medical setting that actually affect, um, the nurse to patient relationship, a doctor relationship, etc. There's also a lot of software. So these are the applications that process the medical data and support decision making from a nurse to a doctor. So some examples, there's EHR, electronic healthcare records software. So there's something called Epic, Cerner, for example, that nurses and doctors use to kind of organize patient histories, order prescriptions, get test results, that type of thing. And that software needs to be easy to use so that these doctors and nurses and patients nowadays can actually access their data in a meaningful way. Nowadays, there's also AI diagnostic tools, so tools that use machine learning to detect abnormalities in, for example, X-rays or CT scans, or even kind of predicting uh, a shortage of hospital beds, that type of thing. And there's also nowadays telemedicine platforms. So the person designing the system needs to make sure everything is all set so that doctors and nurses can allow for virtual visits because a lot of times you will see a doctor virtually. So you have to make sure that the system can handle that amount of that load, basically. Then you would have data. So the data in a healthcare setting would be the medical information. So you'd have patient records, test results, real-time vital information. So you'd have things like name, age, medical history, allergies, prescriptions. All this data needs to be stored and collected, right? So you need to really have the ability to do that, to store data on whatever you need. Blood works, images, lab reports, vitals, heart rate, oxygen, temperature, all this stuff is connected, is data that doctors and nurses use to really help make sure you're healthy and that you thrive. Then you have different processes, so you have different workflows that kind of ensure everybody has access to what they need. So, for example, you have a patient registration process, potentially digitally. You have prescription ordering in pharmacy via the information system, kind of automates prescriptions to pharmacies. You also have data being sent to billing and insurance. And then sometimes you'll even have these AI risk detection programs. So it identifies patients at high risk based on their data. So there's like rules around this and processes around this and ordering prescriptions and registering a patient. And the last thing, of course, you have people, which I talked about a little bit. These are all the healthcare professionals and patients within the system, right? Within the MyChart or Epic or whatever. So you have doctors and nurses, you have patients, and you have IT staff. You also have, pharmacists, insurance companies, the people that work there as well. So overall, the system is huge, right? I'm gonna write system is huge. That's a H. There's a lot of different components, right? There's the five components of the information system, all kind of relating to each other: hardware, software, data, networks, and people, all to perform a shared function for different users. So how these components relate. So here's just a simple example. A patient checks in, people using a digital kiosk. So that relates to, hardware, software. These are the components. So the patient uses the hardware, the patient uses the software. The hardware and software also relate. They get their medical history, so the patient needs their data, and then, you know, the software needs to show the data. The software needs to be updated with the data, that type of thing. Um, so they can enter new symptoms and request lab tests. So the processes basically, govern how the data is distributed. They interact with the software as well and with the people. The people are affected by the processes. You also have different lab equipment, the hardware and software for the different labs, the physical stuff and the digital stuff. They process blood tests. Results are automatically updated. So this affects software data and hardware. You have AI tools potentially that analyze the results, um, alerting the doctor to a potential issue. So this relates to the people and the different processes. The data needs to go to the doctor. If a medication is needed, the system sends a prescription to the pharmacy. So you have different people here, different software for the pharmacy, different hardware going on at the hospital and the pharmacy, and then the software level for the prescription, and then who gets access to that data. And then you all integrate all of these components. Hospitals try to improve efficiency, reduce healthcare errors, and overall enhance patient outcomes and patient care. So next, I want you all to think of AI. We've been talking a lot about AI. So think of AI as a system. And there's this kind of newish model called an AI factory that really treats AI as a system involving multiple components. So instead of just thinking about supervised machine learning or input output, think of AI as an actual system. So if you think of it this way, think of it as a combination of technologies, algorithms, and processes to perform tasks such as learning, reasoning, problem solving, decision making, and pattern recognition. So all of these things can kind of go into AI as a system. One way to think of AI as a system is to use the AI factory model, which I think is a really good uh, way to kind of visualize what AI actually is. So the AI factory model is really a framework for thinking of AI as a system. So again, systems thinking, different components, right? So let's break down the different components of the AI factory. So AI, when you talk to your friends and family and colleagues, etc., you can think of AI in terms of these different components. Because you can't really have AI without these things, right? So you have data, you have what's called the data pipeline, you have the algorithm development, you have the infrastructure, and you have this thing called the experimentation platform. So the first component is the data. Of course, we always talk about data. The data goes in. Um, Everything starts with data. So the inflow of data. So you really probably don't need another definition here, but this is really the foundation of AI, right? Structured, unstructured data used for training models and making predictions and recognizing patterns. So if you look at the first component, this is the AI factory model here. I'm going to write AI fac. The data goes in to the data pipeline. So there's different types of data that will go in, right? In healthcare setting, you'll have the electronic records data, like I just talked about, patient demographics, diagnoses, medications, X-rays, MRIs, CT scans, heart rate, sugar levels, step counts, drug efficacy, uh, adverse reactions, tons and tons and tons of data, right? So you need the data first to really go into the data pipeline. So you have this data. The data goes into what's called a data pipeline. That data pipeline is kind of a set of procedures, a process. So it's a process for gathering, cleaning, normalizing, integrating, and securing company data. So here you have gather, clean, normalize, and integrate. So what that means is you basically gather all the data and sort it into, what it needs to actually information to function. You need to make sure it's clean and that there are no missing data, that everything is kind of up to date, that it can be analyzed. And there are people and all these different uh, processes. You need to be able to normalize the data. Normalize, basically, you'll learn more about it if you take a database class, but there's a way to actually structure the data so it's in different forms. So there's like first normal form, second normal form. We won't really talk about that in this class, but you need to make sure it's normalized so people can actually use it. And then integrating it into different areas. So you're actually integrating the data that needs to be kind of put together. Um, so making sure your data is clean, it's moving through securely, and you need to secure the data as well. So making sure your data is encrypted. Um, so if you know all the patient, if the data for each patient, you need to make sure that that individual patient has all the data integrated to him or her, um, and it's not, your CT scan isn't over here, your medical records aren't over there, your X-ray images aren't somewhere else. All of it is kind of integrated together in your profile. So some examples here, pipelines for EHR data. So patient records from multiple hospital systems, converting them into a common format, and then loading them into a potentially AI model for analysis, or even just an analytics person for analysis. Imaging data, sending X-rays from hospitals to cloud-based system for actual analysis in real time. And your genomic data, for example, DNA sequencing, cleaned and prepped and normalized and integrated into your profile. Then you have another component. So you have what's called the algorithm development component of the AI factory. And this is really what uh, we talked about the last few weeks. We talked about supervised, unsupervised, reinforcement, that type of thing. So you need to actually assign, you know, these different types of AI to that data once it's cleaned and normalized and integrated. So these algorithms, you need to basically associate them with different tasks. So you have to select the algorithm for whatever type of task you're actually going to use. So you need to do supervised learning for certain tasks, unsupervised learning for certain tasks, as we talked about. And all these things can be integrated together, right? So you have supervised, unsupervised, reinforcement, all kind of together to analyze your healthcare record. So an example here, the process of training AI models to detect diseases, predict patient outcomes, assist a clinician, whatever kind of task you're actually doing happens in this component. So for example, AI for cancer detection, for patient deterioration, and then drug discovery. So it depends on the actual different tasks and what type of AI that you'll actually use. But the data step is before this, the D for data, and it goes into the algorithms. And you would, in theory, um, define this by different tasks. So cancer detection, patient deterioration, drug discovery, and that equals the algorithm. So the data goes in. So for each task, you assign an algorithm, and then that would move on in the process. The next component is infrastructure. So you can't really have any of this without infrastructure. The infrastructure kind of houses everything. This is the backbone of the AI factory. This is basically the cloud. We'll talk about the cloud after your first exam, so you'll understand this component a little bit better next week. So this includes cloud hardware and cloud software and networks that actually manage the data, storage the data process and or store the data process and move the data along. So in healthcare, there's a lot of different types of cloud infrastructure out there that run kind of AI models securely and effectively. So here's an example, cloud computing, AWS, Google Cloud, and Microsoft Azure have a lot of different healthcare tools. AWS has, Health Gen AI. Epic is also a really healthcare centered cloud company with a lot of different types of tools within this cloud infrastructure, like software and AI models and that type of thing. So if you look, if you just Google Epic AI cloud, you'll find that. There's also examples of AI in wearables and then on-premise infrastructure for hospitals because some hospitals might actually need the infrastructure on site for privacy reasons. So something to consider based on the actual project that you're working on. And then you have what's called the experimentation platform. So after the infrastructure, everything goes into this little kind of sandbox area where the analyst like tests everything, the actionable tests that kind of creates the automation. Um, so this is where you test, refine, and optimize your models and then predict different outcomes to make actions basically. So this is really where the analyst lives. The analyst will take all the data, select all the algorithms, and then the infrastructure that kind of goes into the experimentation, right? So all these relate, and then a lot of these go into experimentation as well. And this is where the analyst lives, right? Analyst. So you start to experiment, you do tests with different models, with different analysis tools, that type of thing, before everything can be deployed in a technological environment, basically. So in healthcare, it's kind of a controlled virtual environment where healthcare models are developed, where kind of analytics happens. Everything is tested and refined before actual deployment for use in real life. So some examples, testing diagnostic tools, um, synthetic data testing, so actually using artificially generated patient data to test AI models without exposing real patient information. And then continuous model monitoring. So this involves tracking model performance to ensure it remains accurate. Um, and all this, we've talked about a lot of this data-driven decision making, and this is really where it happens, kind of the experimentation phase or component of the AI platform, the AI factory. So MIS and the AI factory in healthcare, we kind of just talked about systems thinking. We talked about what an information system is, and then I wanted to really relay that or relate that to AI because we've been talking a lot about AI, and AI can be thought of as a system as well. So we talked about the different components of MIS. Remember the different components all kind of relate, right? You have hardware, software, data, processes, and people. And then the AI factory, you have data, data pipeline, the infrastructure, the algorithm, and the experimentation. So all those things kind of relate to each other, right? So when you think of these things, think of them as a different component. This relates to this relates to this, and not so much in isolation. And all these, pieces or components affect each other. I don't know if I'm spelling this right. Sorry. Okay. So what I want you to do now is there's a short video that I would like you to watch. You don't have to do anything with the discussion this week because you do have an exam. And I want you to at least think about these things in terms of AI systems and information systems. So watch this short video. It's a news video about kind of an experimentation platform in a hospital. And there's all these different components that they'll talk about in the news article. So while watching the video, think about the data and the data pipeline, the algorithms behind the scenes, the cloud, the infrastructure going in to process all this data, and then what would be the experimentation to be tested. And then the news article also talks about if AI will replace nurses and doctors. So just kind of think about that as well. You don't have to discuss this stuff in the discussion post, but I think it's a good exercise to apply the systems thinking by watching this video and just kind of breaking down the components in your mind. Okay, and that's all I have for this week. You do have an exam, so please take the exam, and I'll talk to you next week.